The next topic we're going to cover is that of precision and accuracy. And these are both important ideas that we will explore them again and again as we repeat labs to determine how precise and how accurate they are. And that's really the only way we can do that in chemistry is anytime we just run one lab once or do it one time, we really don't know too much about our precision or our accuracy. But as we repeat it, we can figure that out. But just to kind of give you an introduction, let me show you a couple things here. So accuracy refers to how close a measurement is to the true value, how right you are. So for example, if we know that I have a predetermined weight, that I know that it's 5.00 grams, and I put it on my scale, and it reads 5.00 grams, then I know I'm right on the true value. But let's say my scale's a little bit off, and it's reading a little bit low, and it says it's 4.95. Well, I'm not very accurate at that point. At that point, I might recalibrate my scale. Precision is how close your measurements are to each other, okay? And imprecision in measurements is caused just by random errors, things that we can't control. And so a lot of times we will repeat an experiment many times to dial in and see where we're making our mistakes. So we'll look at some examples here. This represents a target, and this represents somebody shooting at a target. Now they have a really tight group, so that's very precise. But if the true value is right there in the center of the target, it's not all that accurate, although it's very precise. Here we have a different scenario. Here we have a nice tight grouping, and it's right around the bullseye, so that is both precise and accurate. In this last one, we have one that's neither all that, it's not very precise. If we turned around and averaged all those together, and if the average ended up with the true value, we might be able to say something more about, its accuracy. But it would have to be an average of those numbers. So we're going to call this precise but not accurate. We're going to call that accurate and precise. And because we're really not so sure about this one, we're going to say that's neither accurate nor precise. So let me give you an example of a chemistry issue. So let's say that a chemistry student performed an experiment and they determined the molarity of sodium hydroxide, and we'll talk more about what sodium hydroxide is later on. This is how it's abbreviated, by the way. Na stands for sodium, and that OH is a hydroxide ion. Let's say his goal was to determine the molarity of that, and we'll talk about what molarity is a little bit later. And he did 3 different titrations. He did 3 different measurements for it. And the molarity was determined to be 0.1020 molar, 0.1022 molar, and 0.1021 molar. Well, if the accepted true value, right, it's that right there, that true value was 0.1021, this is a pretty accurate determination. He's just 1 beneath it and 1 over it on that one, and that one's spot on. As a matter of fact, if you averaged all those together, you would come up with the true value. So this student has actually performed a titration that was both precise and accurate.